Hey everybody, in this episode we're going to look at how Python deals with variables. And I have to say Python deals with variables extremely well. So Python is great for this sort of stuff. Let's start off in our idle window. Let's create a program called variables. And let's end the program with a full stop. If I want to declare a variable of type integer, a whole number one, and give it the value, let's call it x, and give it the value 6, I use the equal sign. If I say x equals 6, we read that as x is assigned the value 6, or x gets the value 6. Now I know in pseudocode we've been using the backwards arrow to represent that, and we set different programming languages to do it differently. So for Python, x gets the value 6. So if I save this, we'll call it variables. That'll be .py, and then I run it. Nothing will happen because we've declared a variable, assigned it to the value 6, but nothing else happens. If we want to print it out, print bracket x, close bracket, then save that and run it, we'll see that there is a variable of type x that has the value 6. So because this is an integer whole number value, because numeric in any case, we can do arithmetic. So if we print x plus 1, save that and run it, it should give us 7, which it does. If we do x minus 1 and save it and run it, it gives us 5. So simply put, any arithmetic operation you want to do, multiply, divide, subtract, add, you can do that on variables that are of numeric type. If I declared a second variable, call it y, and we give the value 5, and we said x, print out x plus y, save that and run it, well, x is 6 and y is 5, so we should get 11, which we do. If we say print out x minus y, and run that, 6 minus 5 is 1, and let's just do multiply, x multiplied by y, and save and run. And we get 30, which is exactly what we'd hoped for. So that's whole numbers or integers. Now let's look at numbers with decimal places. Real numbers are sometimes called floating numbers. So if I declare a variable x, and I say x gets 6.0, save that and run it. It prints out 6.0, and note that that is not the integer value 6, it's the real value 6.0. Because it's got a decimal place after it, that means it's a real value. And the same if I said x is 6.56 and save that and run it, it's 6.56. If I add 1 to that, no surprises there, it'll be 7.56. It's worth noting, and this is important as it goes on, we're adding a variable of type real, and we're adding 1 to it. The number 1 is an integer. Typically with arithmetic operations you can't add two different types. So what Python actually does is convert that 1 to 1.0 behind our backs, and then it does the operation like that, because it's always better to be adding operands, or the two values, of the operands of the same type when you're doing an operation like that. So that's real values. Let's try a character value. Same as in pseudocode, if we use a single quote to represent a character value, so if we declare a variable x of character type by saying x is assigned single quote @ single quote, what that means is the variable x, think of it as a bucket, is now storing the symbol @ sign. So if we run this, we're printing out x, and x is the @ sign. Another type of character type could be a colon. So if we save and run that, it's a colon now. X could be the capital letter T. So what that means is it's a container, a bucket, with the letter X printed on the outside of the bucket, and inside that bucket is the character T. So when we run that, X will be T. X could also be the character 4. And when we save and run that and print out X, it'll print out 4. Now that is not the number 4 at all. It's not the real number 4 or the integer number 4. It's the character 4. So what difference does that make? Well, the difference it makes is if I try and add 1 onto the character 4, that's the same as trying to add 1 onto the character T or the character @ symbol. If I try and run this, it should give me an error because the character 4 can't have 1 added onto it no more than your house number can have 1 added onto it. You can't go out to your house number and try and add 1 onto it because it's a code. It's not an arithmetic value. If we run this, perfect. It gives us an error saying you can't add a string, a character, to an integer. So it's saying no, we cannot do that. So we don't want to do that at all. We don't do arithmetic operations on string or character types. So as we're mentioning strings anyway, let's see how we declare a string in Python. Well, it's just double quotes from inverted commas. So if we put in the phrase this is a string in double quotes, Python will know that's a string type, and if we print out that as a variable, it'll read it as a string type. Let's say we put in please input a value. Colon, and save that and then run it. It prints out the phrase please input a value. It'd be cool if we could read input from the screen, and Python has a built-in function to do that. So if we declare a new variable, call it y, and we say y gets the value of input, I-M-P-U-T, open bracket, close bracket. What that means is whatever I type in, it'll store it in a variable called y. So let's save that and run it. So let's say I type in hello. Nothing else is going to happen, but the variable y did store the word hello. If we want to, we can see it by printing out y. So if we save that and then run it, if we input the value hello, it's printed back out the word hello to us because it stored the word hello in y. Let's do something a bit more complicated now. Let's create a program to convert Celsius values into Fahrenheit values, a temperature conversion. So let's say please input a value in Celsius. Read in that value, and then we convert Celsius into centigrade by multiplying the value by 2 and adding 30. We'll add in a message as well, just printing out the value in Fahrenheit is colon, close bracket. Alright, so if I save and run this program is not going to work at the moment. So we convert Fahrenheit to Celsius by adding, multiplying by 2 and adding 30. That's the standard formula. So let's look at our code again. X gets print a value to the screen, print that out, then Y gets whatever's input, and then what we do is print out the value in Fahrenheit is, and multiply whatever's input by 2 and add 30. So strangely enough, this program will not work, and I'll tell you why after we see it crash. So if I put in a value of 40, it gives an error, and if we look at the error, it's the same error we got when we tried to add 1 onto the character x. So do you remember when we declared a character? The character 4 was assigned the variable x, and we tried to add 1 onto it, we got an error. This is the same error. So when I try to multiply y by 2, it's giving an error. Why is that? It's because the variable y is whatever you typed into the screen. Now, Python always reads whatever you type into the screen as being a string type. So we need to tell it explicitly. Take whatever comes onto the screen and turn it into an integer. So if we put int brackets around input brackets and save that, now it will convert whatever we type in, the number 40 in this case, from a string, because it read that in as quotes, double quotes 40. And then we tried to multiply double quotes 40 by 2, so it didn't work. So now what we're saying is take it, convert it into an integer. And then if we run that and type in 40, then it'll tell us that the value 40 degrees centigrade is 110 Fahrenheit. Let's run this program again. So 0 degrees centigrade is 30 degrees Fahrenheit. So it works now because the input we're typing in is converted into a numeric type. So that's the basics of how Python deals with variables. Thanks very much, and we'll see you on the next lesson.